Hello? Hello, can you hear me? Hello?
Yes, we can hear you.
Yeah.
We can hear you, Professor.
How are you all doing?
I'm sick.
Beware. All right. I have here tonight. Let us let me show you what we have this week. Last week give me 1 minute. Let me close some of these folders. I'll close this one. Okay, which other one? I think I opened so many of them. All right, I think we are good now. Probably. Now, what we have this week, we have is week 15, a repetition of what we have last week. We have to complete chapter 8. Not every part of the chapter, but the areas we need for the class. Then the assignments, classwork 12 is not extended, that is due tonight, but you can still submit it tomorrow. Homework 8 is now extended to Sunday, December 4. And then test 2 is now, the due date is extended to Sunday, December 4 as well. So this is the things that you need to cover this week. Now, let us begin. Last time we met, we started confidence interval for the mean, and I explained what it is, and we solved some examples. Now, the one we did that week was for large sample. We say that sample is large statistically when it is greater than or equal to 30 and greater than or equal to 30. Now, we also did how to compute the minimum sample size using this formula. We did that one. Now, let us look at the confidence interval for the mean, where the sample size is small. In that case, n is less than 30. To do that, we use a different table that is called the t-distribution table. Now, let me show you how it looks like. I remember I told you to print these statistical tables and keep them handy. This is the table we are using for last time, table 5. Now for this one, we're using this one, t-distribution. It is called student t-distribution table. That's one we'll be using. And for confidence interval, remember confidence interval is 2 sides, left side, right side. So we'll be using for the alpha, we use the one that have double prime, not the one that have single prime. We'll have double prime. And this table is based on what we call degrees of freedom, call it DF. You see it, I explained it more here. See, DF means degrees of freedom. And for t-distribution, it is found by doing n minus 1. N minus 1. Okay. All right. 1 minute. Hope I have the right tensors. Okay, good. So let's see how this works. I will first of all show you how to use the table to find the critical values. And then we can now do example. The first attempt is this one. It says find T alpha over 2 value for the following confidence level. Mr. Leroy, are you here?
Yes.
I sent you an email. So have you checked your email?
Yeah, I seen the email.
Okay, good. So you know what to do then. All
Yeah.
right.
Thank you.
You're welcome. Now have 95% confidence interval. 95% confidence is say find the T alpha over 2 value for the following confidence interval levels. 95% confidence interval with n equals to 22 samples. 99% confidence level with n equals to 10. So you can see that in each case they are less than n is less than 30. And when they say find T alpha over 2, that means they're asking to find a critical value. If you remember when we did for the other sample size, we used P over 200. We cannot use that here. So because we're using the T distribution table. So what you're gonna do now? Let's start with the first one, 95% confidence level. So if it is 95% right here, that means their chance of being wrong is 5%, and 5% is 0.05. So you're gonna do 0.05, and the sample size is 22. So put 22 right here. Now degree of freedom is n minus 1. That means 22 minus 1, which is 21. So critical value. Now we'll be looking at under degree of freedom 21 for alpha 0.05, and we'll find our critical value that way. So under degree of freedom, 21 degrees of freedom and alpha 0.05. Let's look at the table. Remember, because this is a confidence interval, we have A double prime. That's where we'll be looking at. 0.05 is right here. Then you follow it to 21. You can see it right here. Okay. See 0.05, follow degree of freedom of 21. You follow it, you can see right here 2.080. So 2.080. We go there and put it. Okay, 2.080. Any question on that? Any question, class? Okay, good. Now, for 99% confidence, they say n is 10, but 99%, that means your chance of being wrong is 1%. So alpha will be 0.01, and n is 10. N minus 1 is 10 minus 1 is 9. For critical value, T alpha over 2. If you look under the degree of freedom of 9 and under alpha 0.01. We'll go there, okay. 0.01 is right here. This is 0.01. And degree of freedom 9. Okay. See? 0.01. Okay, right here. And degree of freedom 9. 3.250. 3.250. So this is how to find the critical value using T distribution table. Okay. Now, having seen that, we can now get to some examples. Remember, when to use, let me summarize when to use T distribution table and when to use the other one, which is the normal distribution table. Okay. We use T distribution table if the sample size is small. See, when the standard deviation is unknown, is known. Yeah, when the population standard deviation is known. Let me put it. When the population standard deviation is known, and Z alpha over 2 values can be used. That means you can use the other table of normal distribution. No matter what the sample size is, as long as the variable is normally distributed. Now, when the standard deviation is unknown and the sample size is very large, you can still use if it's very large, you can still, if it's unknown and the sample size is large, then the sample standard deviation can be used in the formula, and Z alpha over 2 can still be used. Yes, but when the population standard deviation is unknown and the sample size is less than 30, then you have to use the T distribution. Okay. Now let's look at an example. The example says a sample of 6 college wrestlers has an average weight of 276 pounds with a standard deviation of 12 pounds. Okay. Now, it says calculate, find 90% confidence interval for the true mean weight of all wrestlers. B, if a coach claimed that the average weight of the wrestlers on the team was 310, would the claim be believable? Yeah. Now, again, let us list our values. The mean, okay, the mean will be, we can get the mean, you can insert the mean from here, insert. The mean equals average weight. So the average weight of 276. The average, okay, a sample of 6 college wrestlers has an average weight of 276 pounds. So it's 276 pounds. And the standard deviation is 12 pounds. Now, this standard deviation is not for the population. They just say the standard deviation of this for these 6 wrestlers, not for the population. So we're gonna use X equals 12 pounds. Now, the mean we'll be using this symbol I use here. I use here is the wrong symbol, because this one is the population mean. The mean we are looking for is for the sample mean. So I'm gonna correct this, remove this. To get the correct character for the mean, I'm gonna look for, take you to the other workbook where it will allow us to get the character, 276 pounds. So let me write X bar is 276 pounds. So the mean for this 6 wrestlers, let me go and get it, get the other character. Okay. So we have, okay, mean, this one here, sample mean. Okay. X bar, I'm gonna make this thing look big so I can see it very well. Okay. 16 X bar. Okay. Equals 276 pounds. 276 pounds. Okay, good. I got it now. Blackware. So I can take it to the, I'll copy it now and take it to the main workbook. We can put it there. 276 pounds. Okay, good. And the standard deviation, because we do not have the standard deviation for the population. What we have here is the standard deviation for these 6 wrestlers. So we use S for the sample standard deviation, 12 pounds. Instead of using delta for the population standard deviation, use S. So now, so for these 6 wrestlers, the mean weight is 276 pounds and the standard deviation is 12 pounds. You said, find the 90% confidence interval for the true mean weight of all wrestlers. Anyway, let's put the sample size. Sample size is n. Okay. N equals 6 wrestlers. Okay. This automatically tells us that we're going to use T distribution because 6 is less than 30. N is less than 30. So that means it's a small sample. Now, next is the let's find the critical value. First of all, let's find the degree of freedom. DF equals n minus 1, which means 6 minus 1 equals 5. And it says 90% confidence interval, which means that our alpha will be 10%. Because if it's still 90%, that means our chance of being wrong is 10%. So our alpha will be 10%, which is 0.10. So now we look for the critical value, T alpha over 2, which will be T alpha over 2. Maybe let me move this thing down so we have enough room for this. So we have more room. Okay, good. So T alpha over 2 may be critical value. Critical value, which is T alpha over 2, alpha over 2. Remember, we have used alpha over 2 because it is two sides, left side, right side. So for the confidence interval. Now, to make this look more like a formula, I'll take you to the other workbook where we can put them in the formula, and then do the calculation, bring it back here to the main workbook. So in that case, let me write these things down. T alpha over 2 is okay. Oh, we can get this from the T alpha over 2 from the you can get this right from here actually. Okay, let's get it. It's called a critical value. We have the degree of freedom is 5, alpha is 10. We go to the table. 5, alpha is 10. So the degree of freedom is, this is DF right here, is 5. And alpha is 10, 10.10. So you can go, you can see right here, under 5. See? 2.015. So we can go and put it in. 2.015. 2.015. Now we can now calculate the error margin. The error margin. This is the part that we need to go and put it in a formula method. Error margin E equals, so that this is the time I will take you to the other workbook so that we can put them in. So instead of, it's going to be T alpha over 2 times standard deviation over square root of n. Let me write these numbers down. Okay. Yeah. 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 We have standard deviation. What's our standard deviation? Is 12. Okay, 6. All right. So our standard deviation is 12. Our n is 6, and our T alpha over 2 is 2.015. Now to put this, to put the formula for error and then plug in these numbers so that they will look like an equation, I will take you to that workbook so that we can put them in. We have this right here. So the error margin E, which is E, equals the formula is this. We get 1 minute. So we get T alpha over 2 T. We got alpha over 2. I don't get alpha from here. Okay, what is the alpha over 2? Okay, times standard deviation. This time we have sample standard deviation over the square root of n. Okay, which is T alpha over 2. We have it from the as 2.015 times, for times somewhere here. Okay. Right here, times standard deviation of 12 over this. N is, there are 6 restaurants, so square root of 6. N is 6 so here. 6. So we can now put this. This is what we're gonna put in the calculator. 2.015 for this one times sample standard deviation of 12 over square root of n, which is 6. So let's go and put this in the calculator and then put our answer in, then transfer everything to our main workbook. So you have 2.015 times standard deviation of 12 divided by square root of 6. Okay. I have 9.87. 9.87 approximately. So I'm taking you there, 9.87. 9.87. So I'm going to copy all this since we got our error now. 9.87, taking you to our main workbook. See? So we found our error margin E as is, so we want to make it is. See? Now, once we find your error, you have gotten your confidence interval. Once you find your error, so we have gotten it. So remember, we started with by writing down the values we are given in the equation. Then we find our critical value of 2.015 from the table. Now we have found our error. So the final stage is to get the critical, the confidence interval. So we can now say that 95% confidence interval is, say, X bar minus error. X bar is the sample mean minus error. Of course, this is error here. Less than mean, less than S bar plus error. See, that's how we get it. So we have it as, our S bar is 276. 276. Okay. Minus error. And our error is 9.87. Less than, I get less than from the symbol section. Less than the mean. Okay. Mean, which is what we are trying to estimate. And then less than, I say S bar, which is 276 again, plus error of 9.87. So like we did last week, once you get your error, you subtract it on the left side and add it on the right side. That's it. That will give you the confidence interval. So when we do this, 276 minus 9.87. Let me write it down. 276 minus 9.87. So you have 276 minus 9.87. You mean 266.13. 266.13. I put it in. 266.13 pounds is less than the mean, less than, on the right side, you add it. 276 plus 9.87. Let's go and add it and see what the result will be. Say plus 9.87 give us 285.87. 285.87. 0.87. So we can now say that we are 90% confident that, because if you remember, this question is about the average weight of wrestlers. So a sample of 6 college wrestlers has an average weight of 276 pounds. So find 90% confident interval for the true mean weight of all wrestlers. So we can say with 90% confidence that the true mean weight or the average weight, so that true mean weights, that the true mean weight of all wrestlers lies between 266.13 pounds, 266.13 pounds to 285.87 pounds, 285.87 pounds. Of course, based on the sample of 6 wrestlers. So all these things that we did here is just to get this, give us this conclusion. So you can see that when I'm grading it, each part of the equation have, points. Any question on this? Any question? Okay, there's no question. Good. Now, sometimes they might ask you to please, if you have question, ask question. I don't respond to text message when I'm in the classroom. You have to ask the question here. So next question here is asked us to say the following data represent a sample of number of home fires started by candles in the past several years. It says this year we have 5,460 home fires started by candles. This one 5,900 home fires, and so on and so forth. And for how many years? 1, 2, 3, 4, 5, 6, 7 years. Say find the 99% confidence interval for the mean number of home fires started by a candle each year. So what do we do? Solution. Something like it is. Oh, you know what? We didn't finish the other part. The other question, we answered only one part. We answered part A, 90% confident, but part B says if the coach claimed that the average weight of the wrestlers on the team was 310 pounds, would that claim be believable? Of course, the answer is no, because 310 pounds is not within the interval. No, because 310 pounds falls outside the interval. See? So that claim is not believable. Would that claim be believable? No, it will not be. See? So that's what this complaint interval helps us to do. Now we can now solve part B, number 11. Solution to this question. In that case, our n sample size is 7. 1, 2, 3, 4, 5, 6, 7. Okay. It's 7. And then this is small sample. So, and sample mean. To find the sample mean and sample standard deviation, these numbers are big. So we're going to use Excel to find them. And that will be a way of showing you how to use Excel to find them as well. So we can, I can open an Excel so we can type in the numbers, find the mean and standard deviation, and then get our confidence interval. So I'm going to write these numbers down and put them in Excel. Okay. I hope you can see my screen. Good. So I have 5460 5900 6090 6310 7160 888440 9930 1 2 3 4 5 6 7. So let me go and type them in so we can get our mean from Excel. And I'm gonna make this Excel to be big. So I'm gonna have 5460. I got 5900. Got 6090. Got 6310. I got 6310, 7160. I got 8440. I got 9930. So I got 1, 2, 3, 4, 5, 6, 7. So mean, sample mean, then standard deviation, ST. Okay. So as you can see from my screen, you can just get them all these numbers right away. The sample mean maybe you get it, put equal sign, type average, it comes up, double click, highlight all these numbers, press the enter key, give it the mean right away. For standard deviation, put equal sign, type stdev.s. This is what you need for sample. Double click, highlight all, close it, and then press enter key. So we have all the things we need. We have X bar 7041.43. Sample standard deviation is 1610.27. So let me go and get this on the section, the formula section. So the sample mean, our sample mean is X bar equal 7041.43. And okay, let me copy it. Paste it in our main workbook. Okay. Which is this one here. And standard deviation, we got it from the from Excel. Our standard deviation from Excel is this 1610.27. The standard deviation is 16. Sample standard deviation equals 1610.27. Now let's find the alpha. It said 99%. So our alpha will be 1%. Since if it's 99%, our chance of being wrong is 1%, which is 0.01. So this is our alpha. It's always, I don't know why it's always changed that symbol to A, alpha. So that's our N is 7 already. So degree of freedom, DF, is N minus 1, which is N is 7. So 7 minus 1, which is 6. So the critical value, T alpha over 2, T alpha over 2 becomes, we look for under the degree of freedom 6 and alpha 0.01 in the table of T distribution. 0.01 is right here under 6. 3.707. 3.707. You got 3.707. 3.707. See? So we have let's estimate the error. Okay. So our error margin, the error margin now becomes error margin E is, let's estimate it. We can now go back to the formula and then estimate our error margin. The formula, remember the formula for estimating the error margin is right here. T alpha over 2 times standard deviation over root n. Okay. So we can now from here, so I'll take you to the main workbook. So let me see. Let me write it down. T alpha over 2. Alpha over 2 is 3 points. T alpha over 2 here is 3.707. Then standard deviation S is, if you have it here already, and our N is 7. Okay, good. Let's go and put them in. We have the error E equals T alpha over 2. Okay, T alpha over 2. Of course, I had alpha over 2 times, okay, standard deviation over square root of n, okay, which is T alpha over 2 is 3.707, 3.707, okay, times standard deviation of 1610, 10.27, so 27 over square root of n. Our n is 7, root of 7, and that will give us some. Write it down. 3.707 times 1610.27 over square root of 7. Let's go and put it in. We take you to the main work, our calculator. So we have 3.707 times, okay, times standard deviation 1610, 1610 0.27 divided by square root of 7. 2256.17. Okay. 2256.17. Now, this thing it will time us out in a minute, in a few minutes. Please, when it time us out, wait for 10 minutes and log back in. Okay, can you hear me?
Yes.
So if you
Yes.
time us out, wait for 10 minutes, log back in so that we can finish this. Okay.